Hello, my name is Rahman Shahiner. This is our presentation about Smart Football Coaching System. This is our index part. We have 9 topics in this presentation which are included in here. Traditional data football analysis methods are inefficient and take a lot of time to complete. We are planning to bring an innovative solution to this problem with the football data analysis system that we will design, which can simulate in-game situations. We aim to both find a share with developing global market and change the inefficient approaches in data analysis methods by combining data analysis and machine learning technologies. Scope bars indicate the main objectives we focused on. The objectives listed in this slide. We have prepared certain project analysis methods in order to carry out the project in a healthy way. The first of these is the black box diagram. Here we simply get the football player shooting data, and as a result of the certain operations, we get meaningful analysis. In our second work, we prepared an objective tree to clarify the steps of the project. The four main branches of the objective tree are functional branch, cost branch, safety branch, and maintenance branch respectively. The functional branch has detailed in this slide. The branches are detailed within themselves as data collection and data processing main parts. In these parts, there are objectives that are determined to be completed. This section also includes detailed and specific objectives of cost, safety, and maintenance branches.
Here you can see the morphological part we developed in our project. In this chart, we examined the titles of ball throwing, ball storing, data gathering, filtering, data processing, and result presentation for our project and made choices among alternatives and determined our design. QFT has been prepared for our project. Thus, we determined the expectations of our customers from us. We have also chosen the technical requirements we need to meet these expectations. Here you can see the main part of the QFT table. In the roof section of the QFT table, the relations between the technical requirements are examined. In the lower part, concrete targets of technical requirements were determined and competitor analysis was made. Stakeholder requirements plays a critical role in market analysis and budgeting. Football clubs, analysts, and Tubitak are our stakeholders. In technical requirements, the radius and the weight of the soccer ball, the radius of the discs that we will use in the ball throwing machine, the engine RPM and torque values calculated based on these values are specified. At the same time, we have some requirements in the electrical and data processing sections. The block diagram is simply as follows. A ball is placed on the ball thrower and so thrown. The player takes a shot towards the target with the thrown ball. At the moment of shooting, the player's body position estimation is made with the camera. 3 actual acceleration values are taken with the IMU sensor. This data is processed and made ready for machine learning, and results are obtained with the machine learning algorithm. As for the mechanical design part, when the literature was reviewed, it was decided that the initial speed should be 10 meters per second. Based on this value, the angular speed of the disk was determined as 60 radian per second, thus 600 rounds per minute. Afterwards, the torque value was determined as 0.9 Newton meter with the processes you will see. The image on the right shows the computer-aided design of the ball throwing machine. The principle of operation is simply the ball is compressed between the discs by the help of the 2 DC motors and it is thrown as a result. We selected a motor with a torque value of 0.9 Newton meter and an angular speed of 600 rounds per minute, which we obtained in the kinematic analysis. This can be seen in the image on the right.
In electrical part, the electrical design of our system has been made. The technical requirements have been determined, and the material choices have been made to meet this requirement. In general, what is expected from the electrical design of our project is to receive three-dimensional acceleration, velocity, and position data via Bluetooth. For the microprocessor, in which we can transfer data via Bluetooth, has been preferred. Data collection was done via 9 degrees of freedom IMU sensor. Elements such as capacitors, transistors are used as side electrical circuit elements. For designing electrical circuit, the selected components are indicated in here. Also in here. determined circuit elements were simulated with the help of the Proteus simulation program, and circuit diagram was obtained in general terms. In addition, the input and output information of the circuit can be checked through this program, and the designed microprocessor code can be tested. For the explanation of the working logic of the circuit in general, three-axis acceleration, velocity, and position data are collected through the IMU sensor. After the necessary voltage manipulation processes are performed and stable values are obtained, data transfer is made with the SAP ACP33 microprocessor. ACP32 microprocessor DevKit C, which has a Bluetooth connection.
Data preprocessing includes some correction on the set, completing missing data, removing duplicate data, transforming, integrating, cleaning, normalizing, size reduction, etc. Data for a machine learning algorithm must undergo some data preprocessing. Raw data is always noisy and can mislead the data's intended use. In data processing application, 80% of the resources are spent on the preprocessing and cleaning the data. The machine learning algorithm will discover hidden pattern among the data, giving us result with high accuracy. Machine learning algorithm includes different analysis methods. Classification, clustering, and regression are these methods. It was decided to use regression applications for our problem. The reason for resorting to machine learning algorithm in this project is the inconsistent result due to quality violation of the performance analysis while performing shoot analysis. Linear regression is a machine learning algorithm that allows revealing the relationship between dependent variables and independent variables. The linear regression method is used to estimate and find the cause-effect relationship between the variables. In the algorithm we developed, the three-axis acceleration data obtained from the sensor placed on the player are independent variables. Our dependent and independent variables which we collected as a result of one hour training from each player will be combined in a table and turned into a dataset. Our model will be trained with this dataset, and the most suitable shooting position will be determined for the players. Since the necessary electrical circuit and machine designed to be used in our project are not yet live, similar data were found to advance the development of the machine learning algorithm. With the help of these data, the path of the analysis to be simulated. The data we use is taken from the Kaggle. For simulation, first we import required libraries and datasets. In the second step, raw data set is visualized for analysis. In the third step, unnecessary columns of the dataset have been cleared so that the result conforms to the requirement of the project. In the fourth part, unnecessary lines of the dataset have been cleared. In the fifth part, the features of the dataset were checked and a list was created to simulate the shot accuracy rate. Then data visualization libraries were imported and data visualized in order to make accurate analysis. After visualizing the data, our filters created. Filters were applied to the data and turned into processed data. And for the final results, our machine learning algorithm has been established and our dataset is divided into train and test datasets. As a result of our algorithm, our score have been visualized and brought to the level and that can be analyzed. Thank you for listening us.